So guys, welcome back. It's Electronics channel with a brand new video, and today I have good news and bad news. Good news, I was finally successful to film and make my LED circuit so I can go green when power supply is on, red when power supply is off. That was fairly easy to do. And the bad news are that I had actually blown up my two boost converters and I might need a new one, so this video might get delayed or the next video might get delayed, I don't know. So I will talk in greater detail about this. So let's get right into the video and you'll see what I have done. So guys, we are farther into our project and I have a little board made right here for the LED indication light. So what this board does is it makes the LED red whenever we have the power supply off, and it makes it green whenever we turn the power supply on. So essentially this wasn't something I made in 2 minutes. This was over period of about half an hour. I was thinking about it and looking for parts, trying to find an idea that would actually work, and I figured out that this is probably the best way and the best solution for this particular problem. So what we have is we have a relay, and we have our ground and a 12-volt rail connected to the coil of the relay. So whenever the power supply turns on, we have 12 volts going to the relay, turning the relay on. Okay, so remember that. Then we have a auxiliary. Yes, there is a auxiliary voltage on the power supply, and it is 5 volts. So whenever you turn, well, not really turn on, but whenever you hook the power supply up to mains power, even though it's off, it's spitting out 5 volts on a purple wire on the 24-pin connector, and that's what we are using to power the red and green LED right here. So to represent the 5 volts, I will be using a 3-volt coin cell battery. So this is our auxiliary positive. Yes, it's black. This is our negative. Yes, it's black. And as you can see, we have our red LED. Now, where is it? This red wire, yes, red for positive, will be representing, when I touch it to this 12-volt battery right here, it will turn on the relay, thus turning the red LED off and green LED on. So when I hook it up like this, now I have a common ground with these two batteries, and whenever I touch the positive, we have green LED turn on. Whenever I release it, we have red LED turn on. So that works quite well. Doesn't really like that when I have bad contact, but I think you got the idea, and that works quite well. So guys, another update. I don't know in which video this will be, but essentially something happened and I am really frustrated right now because I spent so much time on something that should have been really easy. Long story short, the power supply was almost complete. Okay, it was almost complete, and I should have been done filming by now. And actually, I was actually supposed to film today all of a review of this power supply instead of doing this, but it happened that I can't film the review today because the power supply still hadn't been complete, and the reason for that is these MOSFETs right here. I don't know if the camera will focus. There we go. So these are, if you want, there is a number for you. These are the MOSFETs from these boost converters. Now, the problem is that one of them is blown. I was doing my testing, and you know, I was doing my testing with everything, and you know, the front panel itself is a big unit. Okay, it's a big unit with all of the connectors and everything, so you have to plug it in right in order for you to actually, you know, make it work. So what I have done is very stupid. I did not plug any of the pots to the connectors, and what happened was, when I turned it on, I heard the click, and that's it. So after that, I disconnected the modules, and what happened was I wasn't able to start the bottom power supply. Okay, so I have two power supplies, as you know, from the computer, ATX power supply, and the bottom one was not going to start. It just did not start, no matter what I did, no matter how many times I tried. It just did not start. So I thought, well, I just blown the power supply. And things got worse when I saw that only one of the boost converters was actually boosting the voltage, and the other one was just spitting out the input voltage, which is 12.6 volts out, with a forward voltage drop of the resistor, which was something like 11.9 volts at the end. So I was getting 11.9 volts, and I realized, well, I have just fried the boost converter, and I will not be able to finish the video at all for 1 month, because I have to wait for another boost converter. So I thought, well, if it's fucked, you can't fuck it up more, right? So I took it all apart. I took a flashlight with a lens, and I started looking all over the components. And what I was doing is I had my multimeter, and I was testing, because I have two identical units. One is working, one is not. So I was testing the good one and then the bad one, and seeing if it's going to react differently. And I figured out that, you know, the diodes were good, the chip did not heat up, you know, everything was good. And I did not see the problem, but whenever I hooked up the bad boost converter to power, it would pull ridiculous amounts of current. So I figured out, I take a thermometer and measure the temperature of the components while I turn it on. So that's when a battery came in handy, which I don't have near me right now, so I can't show you, but it was a 12-volt battery. I hooked it to power, and you know, first I was touching the components, and then I was just testing it with the thermometer, and I didn't see anything, no reasonable increase, except the capacitors. The capacitors were warming up. So I thought, okay, well, we just have a short within the capacitor. So I took it apart, and you know, I took the heatsink off, and I was just, you know, powering it on, seeing if anything happened with the transistors or diodes, because as you all know, when it has a heatsink on it, it will stay cold even though it's shorted out. And 99% of the time, MOSFETs fail closed. So I figured out that would be a good way to test it. And guess what I found? I found that one of these cheap Chinese MOSFETs, absolute piece of crap, was blown and absolutely shorted gate, drain, and source. So, I replaced it. I replaced it with one of these MOSFETs, and these are Dixie's, whatever the number, IXH. Oh, you can read it like that probably if it's going to focus. Come on. There we go. It's a Dixie's IXFH20N60. So these are MOSFETs, and I changed one. It was working fine. I was able to boost the voltage without load. Never do that again. I always have a load. So I thought, okay, hell yeah, I will just replace the second MOSFET as well, which, by the way, this is the MOSFET. This is a good MOSFET. In the second one, so they are exactly the same. Okay, so I did that, and to my surprise, when I was testing my boost converters, I was only able to go to 25 volts, and then the OCP popped. All of the usual suspects. Why did that happen? There is a good explanation. I went back to the data sheet and I saw that they're not really designed for high-speed switching applications. And, that wasn't good at all. Their gate charge was just too high for them to go, to the speeds of the boost converter. So whenever we had short pulses, that was fine, but whenever we got to the higher voltage boost level, the OCP would pop because they wouldn't close, they would stay open, and it couldn't handle it. So I thought I have to find a proper MOSFET. Now, where do I find the proper MOSFET? Well, as you all know, I have a video, which by the way had reached 18,000 by now views. Thank you very much. It's a the usual cool power supply right here, absolute success. So what I thought is I have blown 2 or 3 power supplies while making this video, and most of them were just components that are on the secondary side of the circuit, so the MOSFETs are just fine. So I took those power supplies, and one of them had 2 MOSFETs, and they're ST Electronics, and I don't remember the number really, but it's 59 amps of currents, source to drain continuous, and 210, if I'm correct, post. So I thought that would be just great for my application. I put one in. I did a full testing with a full load, and I was able to successfully pull 200 watts of power. So that was 50 volts and nearly 4 amps of current. So that was just fine for my application. And I thought, well, that looks really, really good. And the thermals were pretty good. So I went ahead and I did the second one. And what do you think? Now it's fixed. I have 2 working boost converters with 2 days of troubleshooting. Changing, 6 MOSFETs by now. And, it works. So the power supply is almost complete. There were some steps I skipped, so I will show it to you right now. So I changed, what did I change? Let's see. Well, I filmed this circuit some time ago. I never showed you the making process, but this is the circuit that blinks the LED. So very simple. As I said before, there will be a schematic in the video description, full schematic of this power supply. So if you want to make something like this, or you just want a reference and modify the circuit, I am okay with that. You will be able to get the schematic online in the video description, and you can do whatever you want with it. And if you have any questions, you can always ask in the comment area, and I will be more than happy to answer your question, because this isn't a simple power supply. This is something that is pretty advanced for at least my level of self-education in electronics field. I think this is pretty advanced for what I am as an electronics hobbyist. And this power supply is a final project to graduate, to self-graduate from a guy that doesn't know anything to a guy that can do something like this. So yeah, full schematic in the video description. And yeah, so you got some capacitors for the output and input. So these are 275 volt, 150 microfarad electrolytic capacitors in parallel. So we have 300 microfarads each at 275 volts. These came out of a plasma TV. They're designed for low ESR. They are low ESR, and they are designed for switch mode power supplies. So that is all good. I also have some capacitors here. So they are this type. They would be foil capacitors. So they're almost 3 microfarads, this one, and this is X2 capacitor, mains voltage 275 volts, and what is it, almost 2 microfarads or something like that. So no, less than a microfarad. And I have 2 units for each boost converter. So these go in parallel, so two groups, and this is for the input. Together, they have 6 microfarads of capacitance, and these are, I believe, 400 volt capacitors. The voltage doesn't really matter because we are using 12 volts on the input. What matters is the capacitance. So this should get rid of the high switching noise that can go back to the power supply, which will be bad because it's not really designed for that, because the CPU buck converters switch at ridiculously high speeds, which allows them the ultimate efficiency, and that noise just doesn't cause any problem to the power supply. But whenever you go to higher currents here, I'm not sure about the frequency. I'm not going to measure it because that doesn't really matter. We're not building a filter, okay? Well, this is essentially a filter, but I don't want really to go into all the calculations and crap. That's just too ridiculous for this project. But this should be just fine for what we are doing, and I think this would do just fine. So it just goes on the input, and off she goes, and that goes on the output, and so we are done. So all we have to do right now is just hook everything up with all the caps and everything, put it all in, hook up the mains power to the front panel, and test it all out. Obviously not in this video. This had been long enough already. So So guys, that's about it for this video. You all know what to do. Like it if you like it, dislike it if you dislike it, and don't forget to subscribe to my channel if you hadn't subscribed already. And yeah, you're going to see some of my other videos on your screen. I really hope you click on some of them and you'll make me the happiest person ever. And yeah, as always, see you in the next video.